The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Thank you for joining today's webinar. Just wanted to give it a few minutes. We have a bunch of people joining, so we'll start the webinar in just 3 or 4 minutes or so. Hi, everyone. Thank you for joining our last global webinar day of the year. The webinar will begin shortly. Just a couple of housekeeping items. So this video will be recorded and available on our website with the link being sent via email. So today's topic will be pushing into IoT full force, IoT and security. My name is Virginia Stroup. I'm the Demand Generation Manager for InfoSim Americas, and I'll be your moderator for today. I just joined InfoSim in September, and before that I was doing business development with Oracle for a few years. So that's my tech background. We also have Karl Lewis, who's a Senior Solutions Architect at InfoSim Americas. Are you there, Karl?
Yep. Hello, everyone. Just to give a little background about myself, as Virginia mentioned, I'm a senior solutions architect here at InfoSim, and over the last 8 years, I've been a packet pusher, managing various network and security devices. I also have a pretty high interest in SDN, NFV, IoT, and anything involving essentially the future of networking.
Great, thanks, Karl. So normally these webinars that we do are very technical in nature, but my background is in sales, so you might have to explain some of the things, like I'm 5 years old, even though I'm obviously much older than that.
Not
So IoT and security, so where do we begin?
Good question. There are just so many different topics to discuss, but I just want to give a brief overview of what we're going to talk about today. IoT is definitely the future. And with all that's been happening in the news lately around IT security, I thought this would actually be a great topic to end 2016 off with. I'd like to touch on essentially three main topics: security threats and concerns involving IoT, creating a strategy for IoT management, and of course the actual how on how you go about managing these IoT devices with security in mind.
Awesome.
Okay. I'd like to start first just by discussing a few of those initial concerns that come with, from a world where everyone and everything is connected. The first potential concern is growth. It's such a simple concept, but as anyone who's worked in IT or networking knows, it opens up a whole new set of potential problems. I found this graph below that shows that we're actually adopting IoT devices 5 times faster than electricity or telephony.
Wow, why do you think that is?
It's a number of things. IP and connectivity are essentially becoming ubiquitous in the world, which are just really simpler ways of saying that Wi-Fi and IPv6 have taken over.
So IPv6 is the latest version, right?
Yep, it has way more IP addresses available for all these new devices that are entering the network world. Just a fun fact about IPv6, there's actually enough IPv6 addresses to assign one to every atom on the surface of the planet. In addition to that, advancements in compute have allowed for the development of like small sensors and other small form factor devices that exist with full networking and storage capabilities. It allows for you to easily make small devices with nano operating systems that could fit, say, in a toaster.
That sounds dangerous.
Yeah, and then of course, when you have all these devices being created, they have to physically go somewhere. One of the most overlooked attack vectors in the age of the Internet of Things is, the fact that these devices can simply be stolen. How do you stop someone from gaining physical control of these IoT devices and using that to maliciously access resources that the IoT device would normally have permissions to do? For IT admins, physical security and managing IoT can just be a nightmare. And of course, lastly, we have what I like to call the usual suspects. This is malware, hackers, and the traditional information security issues we're used to dealing with in IT. IoT devices are not immune to these, which actually leads me to the next point. Um, I actually like this slide, the Internet of Crappy Things. This is actually a title of a blog post that I read a while back regarding the current situation we're seeing with all this growth with these embedded devices. As we see things like smart coffee machines, smart fitness bands, and smart TVs make their way into the consumer market, a new problem emerges. Just like PCs, these devices are susceptible to hacking. Most of the guys who are developing these devices are having to deal with new problems in the realm of security. I mean, just imagine someone hacking your smart home or that cool new car wash down the street that has these smart controls or that cool new web camera that yeah, wait, that's already kind of happening, right?
Yeah, I actually recently got my mom a web camera cover for her laptop.
Yeah, I need one of those.
I know, I've already been able to hack into your camera.
No. Anyway, exactly. It gets even more interesting when we actually start talking about users and how they're using their data with these devices. The last thing a user is probably thinking about when they connect their smart fitness band is firewall rules and malware. Um, they don't think of it, they don't think of those things because they think of the fitness band as a fitness band. And the fact that this device could potentially create attack vectors doesn't even occur to them. Um, this places kind of, increased pressure on vendors to ensure that their devices are secure, but even that's a best case scenario. For these vendors, they focus on functions and appliances, and the idea of malware is an afterthought at best.
So I remember you talking about an IoT issue that happened recently, right?
Yep, very recently, actually. One of the biggest DDoS attacks in history happened against a well-known security blogger just a couple of months ago, and it was a result of a botnet using a pretty well-known malware called Mirai. What's funny, to me anyway, is that Mirai isn't exactly good code, but I guess what really matters is it worked.
How's that?
Uh, it's essentially a bot that scans for vulnerable devices by testing out if the device uses a set of common credentials. It then performs a set of attacks that makes the device generate legitimate looking traffic, a la DDoS, slowly eating away at the target's capacity, and then rinse and repeat. There are just over 60 common usernames and passwords built into Mirai, but even with only that few, Mirai was able to find hundreds of thousands of devices to generate over 600 gigabits per second. I mean, even Deutsche Telekom recently had an outage that was a result of hackers trying to use Mirai to turn, user routers into botnets. This is really just the beginning too.
So have there been any other incidents like that?
There have been, but there's two really cool examples I want to talk about how security and IoT can go hand in hand, in a good way and a bad way. This was pretty cool. The Nest thermostat, a device I personally think is awesome. It allows you to remotely manage your home temperature, gather other data, but this means that this device actually needs to have network connectivity. Um, but a pretty smart professor was able to actually jailbreak this device just by using its USB port and a Linux, distribution. Right? Again, we come back to physical security. After doing this, they could get information such as your Wi-Fi password and different information about other devices that are on that same network because the data on the Nest itself wasn't even encrypted. It gets crazier when you start thinking about how they could use this device to exploit things like ARP, just to have other devices on the network exchange data with it. And I mean, in a few minutes, your home hacked by your thermostat. I mean, it's a strange world we live in.
Yeah, getting into hot water with that one.
Yeah, that's just one of the many exploits you can do with this device. This picture in the slide is funny to me because it's actually showing how someone used the same exploit to turn the Nest into HAL from one of one of my favorite movies of all time, 2001, A Space Odyssey.
Oh man, that's a classic.
Yeah, yeah. Hello, Dave, right? Yeah. Anyway, movie references aside, there is some progress here, right? One of the internet buzzwords around IoT recently is what's being called the Internet of Cows. Um, the Internet of Cows. There are startups that are making small devices that allow farmers to monitor the health of their cows, their movements around the farm, and just general inventory. I mean, besides being a cool tagline, though, I think the Internet of Cows is an example of how cloud and IoT can work together to solve real issues. I mean, imagine devices being able to monitor human health. It's really just a glimpse of the future. Of course, seeing as data like that, human health is extremely sensitive. It again brings up the question: if you have this data and it needs to go somewhere, how do you make sure it's secure and on the node and in transit?
I think that's a great question to jump into your next section.
Agreed. I mean, I could talk all day about the events going around, IoT, but let's get to the meat of it. How do you actually start managing these devices? One of the first things any business needs to think about when they're beginning to leverage this IoT technology is simply developing a security strategy. You have to think about four main topics when you do that: configuration and control, provisioning and authentication, monitoring and diagnostics, and of course, scalability. One of the first components is just basic firewalling and network segmentation. It seems simple, but a lot of people, for ease of use, will just place their IoT devices on the same Wi Fi connection as their corporate machines. Or even worse, they'll actually plug these devices into one of their corporate user VLANs. This is a bad idea. You have to identify the who of your network and ensure that the data transmission between these nodes is controlled by a device of some sort, preferably a firewall. Also, keeping IoT devices on their own network segment is still one of the best approaches to limiting the potential impact of a compromised IoT device. An example, just create a separate Wi Fi network that's only used for your IoT devices. You can even not broadcast that SSID so you don't get users jumping on there looking for free Wi Fi, right? You can also create the necessary firewall rules to only allow access from these devices to the devices and nodes that they need to talk to. I mean, this could be your IT admins, an IoT controller, a data collector of some sort, and then of course mercilessly block everything else.
Okay, so at what point are we going to discuss McAfee antivirus?
Um, like how to uninstall it. I mean, yeah, not happening. the The next component of that strategy, in configuration and control specifically, needs to include how you plan to actually manage these devices. Most of the time, you won't have someone sitting right next to a device or a controller. Remote management just becomes that much more important. Any kinds of management traffic, whether SSH or RDP, should securely be encrypted across the internet. Setting up a VPN is probably your best bet. Best bet there, as simply opening up your firewall to the world is exactly how you get hacked.
Yeah, sounds like it.
Yeah, I've actually logged into firewalls in the past that had rules permitting access from any device to any source. And inevitably, I would always get the call from a customer asking why their root password just doesn't work anymore. I do a little bit of troubleshooting, and I would have to respond, you may have been compromised.
Oh man, nobody likes compromises.
Right. Most companies these days do have VPNs, luckily. But even then, you should do some additional rules in place on that VPN to only allow access to the devices necessary based on the person logging in and their role within the company. I've set up similar policies in the past, and it goes a long way towards securing these nodes, and essentially limiting your attack vector. Which actually brings me to the next point there, right, with provisioning and authentication. Who are you letting into your network? How do you know they are who they say they are? Authentication is huge. I've seen all kinds of situations where someone gives out, say, their VPN credentials to another colleague just to allow them to have access to something really quickly. It's an innocent gesture for the most part, but then that person writes the password down, shares it with another person, and so on and so on. I can't stress this enough, but each admin needs to have their own credentials with the appropriate permissions. You could use something like dual authentication, like using a time-generated token, like a Google Authenticator, and a known remembered password. To start to try to mitigate some of these problems and these behaviors. Once you have access to the devices and you've made sure the right people are accessing the right resources, now comes the fun of actually configuring these nodes. But wait, is there accounting? Do you know who's actually making the changes? And do you know when they're making the changes? Can you correlate that information? This is something I'll dig into a little bit later, but it's important that you move away from, cowboy IT, as I like to call it, and storing configuration data on someone's local machine. It's just yet another way someone can learn how to exploit your IoT devices and IoT gateways. And of course, it's one thing to have these rules in place, but you also need a policy to solidify these technical requirements. Each of these requirements should be understood by the staff operating these devices.
We know everyone loves staff training.
That's exactly what I was thinking. Unfortunately, it's a necessary evil, like taxes or learning how to read.
Man, I'm still working on the last one.
All right, moving on. It's one thing again to set up these policies and set up doing authentication properly, but you also have to maintain and monitor these devices as well. Being alarmed when an event happens keeps engineers on top of things, and I personally use logs and alarms throughout my day to troubleshoot and fix issues all the time. If the IoT doesn't support, the ability to log, which I would assume is rare, you can still give meaningful information from the upstream device, whether that's, an access point, firewall, or a router. And then of course, comes the fun of making sure that the traffic that these IoT devices are generating is exactly the type of traffic it's supposed to be. Um, you know, this is where something like an IDS or an intrusion detection system really shines. These devices have the ability to identify patterns and signatures of common attacks and can let you know immediately exactly what type of security concern you're dealing with in a given incident. It takes some of the human element out of the equation, but it enables us as engineers to troubleshoot and mitigate attacks more effectively.
Okay, that sounds helpful.
Yeah, and I've used these in the past, like I said, and they're extremely helpful. And I think the next thing to keep in mind here, as we talk about things like IDSs, is that reactive and proactive measures should work together when you're monitoring your devices. Everyone places this huge emphasis on being proactive, but that has its limits. You still need to be able to react when the unforeseeables occurred. They really do work hand in hand, and both should be a priority when you're monitoring.
Okay, so what about scalability?
Oh, yes. So, in my opinion, this is actually one of my personal favorite parts about StableNet. As the number of IoT devices increases daily for IT teams, all of these strategies I've discussed have to be scalable. It's one thing to secure 50 devices on a single site, and it's an entirely different beast trying to secure 5,000 across, a region or a globe.
Yeah, I can see that.
And then the strategy I'm talking about, and having these standards in place is really just the framework we can use to start building our automation around, which will enable that scalability. Having an admin type in commands for each switch port that each IoT device is going to be connected to just isn't feasible. With standards and just some initial investment in developing, the strategy, um, you know, we can help you design scripts to do most of the heavy lifting, freeing up our brains to do more strategic tasks, right?
Right, that's good. I need my brain space for random song lyrics and trivia.
Yeah, I won't mind for new age cuisine and pictures of my dog.
Well, that sounds an awful like a lot like what we do, doesn't it?
Yes, it does actually. It sounds like exactly what we do, which leads to my next section. So you've started building out your strategy, but how do you actually configure and manage it? Specifically with StableNet. Um, and the first hurdle here is what I like to call the data problem. You have all this useful information. You know exactly how something needs to be configured, and you know how it should be configured. You're receiving traps and logs from your network devices and your IDS, but you have 10,000 devices. In my NetOps past, I've fallen victim to this exact problem. Ended up making my job a lot more complicated just learning how to do something with all this data. It's like what an old instructor told me. It's great to have everything logging, but who cares if no one's actually looking at doing something with those logs? StableNet has many different features that can help you implement and enforce your security and configuration strategy. But today, I really want to focus on two of them. The first is our policy checking engine. As mentioned earlier, it's important to know who are the nodes in your IoT network and who they're allowed to talk to and on what ports. When you're dealing with a distributed network, human error is inevitable. Our policy check engine allows for you to build what we call snippets to create policy jobs that are modular and highly customizable. You can run these policy jobs against many different devices on a given interval and be alerted immediately when something is or isn't where it's supposed to be. For example, a simple, an example I'm showing here in the slide is just creating a policy check job that will check access lists against different firewalls just to make sure you don't have any holes in your remote sites. You could also design a policy to ensure that the right parameters are being used for your VPN configuration, or you could, create a policy that checks that every device is using AAA, something like TACACS or Radius protocol for, authentication, as opposed to local auth. Or, I think you get the point, right? You can do a lot with it.
Okay, so yeah, so basically we're just making sure that everyone's following the rules.
Well, yeah, but it's a little more than that, right? We are also providing a tool set that allows you to build out the security strategies we talked about earlier, and turn them into real technical sanity checks. Plus, I didn't mention that these snippets serve another purpose. You can actually use some of these same snippets to help you with onboarding and configuring new or outdated devices. Again, helping you with that scalability. We can use something called a configuration or a snippet-based configuration job to accomplish that. Lastly, along with these snippet-based policy checks, we can actually use custom scripts within your StableNet deployment to generate alarms for technical and non-technical users. And moving on to the second feature, status alarms. As I mentioned earlier, proactive and reactive measures need to work together. Status alarms allow for you to take something like a syslog or an SNMP trap message and generate an alarm for the appropriate support or security team to respond to. For example, you can create a status alarm that looks for a specific syslog message ID that may be, or you could have it look for a message that may show that an IoT device was managed from a non-VPN IP address, or you could have an SNMP trap that indicates when an IoT device MAC address is changed that the IT team wasn't even aware of. This stops the admin from having to log into the device to scan through hundreds of logs or possibly thousands of logs, or at worst, it tells the admin an event that occurred that they otherwise wouldn't have even been aware of. I think another cool feature of these status alarms is based on that trap or syslog, we can actually trigger an event. Like shown here in the slide, you can back up the device once the status alarm is triggered. You could also do other options within StableNet, which to me that's one of the coolest features.
Okay, so it sounds like it does it all for you, basically.
It really does. But still, it places the control and strategy in your hands, which actually leads to something I just kind of briefly want to touch on, business value. When it comes to managing IoT, there's a lot of strategy that needs to come into play. Um, even to this day, security frameworks around IoT and standards are still being developed. However, the best approach is a combination of manual and automation, of man and machine. And with StableNet, we're taking care of those boring, repetitive tasks while enabling users to start thinking about how they want to tackle these security issues in the way they feel is best for their organization. With each step and the inevitable exponential growth of IoT, having an approach that is both secure and scalable is in every IT team's best interest.
All right, sounds like the best of both worlds.
Yeah, I completely agree.
All right, so we could go on, but I think we've covered most of the highlights. So I just wanted to thank everyone for joining us for our last Global Webinar Day of 2016. Just as a reminder, this presentation has been recorded and will be made available to everyone via email.
Thanks for joining, everyone.
I also want to wish everyone a Merry Christmas and Happy Holidays.
Happy holidays.